Captain, we've got activity in Echo 9.
Initiate Operation Leviathan.
Hello everyone, and welcome aboard. In my previous video, I showcased a fully functional submarine built with Create and several other mods. After that, one question kept appearing over and over again. Can it be built in survival? Well, I accepted the challenge, and after countless design changes, the answer is yes. Today, I'd like to introduce a survival-friendly submarine capable of diving, launching torpedoes, and firing missiles. Redesigned, improved, and ready for deployment. Let's start with the most important system, the one that makes a submarine, the diving system. The diving system consists of two separate subsystems, the oxygen system and the ballast system. So let's begin with the ballast system. The ballast system consists of four main components: a ballast vent, a ballast tank, a motor that powers the system, and a pipe that transfers water from the vent into the tank. The ballast vent must face a water source on one side. It also needs a redstone signal to activate the pumping process. While the number of ballast tanks does not significantly affect overall buoyancy, it does influence stability, as well as the speed of diving and surfacing. Through testing, I found that the optimal fill level for stable depth holding is around 3.1 units of water. At this level, the submarine can maintain a relatively steady depth with minimal adjustment. However, it is still not perfectly fixed in place, and although it may appear stable in real time, that is not entirely the case. Depending on slight deviations from this value, the submarine will either slowly sink or gradually rise. This limitation comes from the relatively imprecise nature of Create mod mechanics. Available sensors and control systems simply aren't precise enough. As a result, maintaining a perfectly stable depth is effectively impossible. Because of that, I designed a diving system based on preset depth levels. The core of this system is a group of altitude meters. Each altitude meter is configured to maintain a specific depth. When a depth level is selected, the submarine will automatically dive until it reaches the corresponding value. Once that depth is reached, the system will continue to hold it until another depth command is received. Based on the signals from altitude meters, the system can switch between diving, surfacing, or depth holding modes. This is achieved by controlling a gearbox and clutch assembly, which adjusts the ballast system accordingly. In this submarine, there are three preset depth modes. The first mode is Periscope depth. At this depth, the submarine remains fully submerged, with only the periscope extending above the water surface. The approximate distance between the water surface and the main hull is 6 blocks. The second mode is Concealment depth. At this depth, the submarine can no longer be spotted from the surface. The approximate distance between the water surface and the main hull is 15 blocks. The third mode is Deep Diving mode. The approximate distance between the water surface and the main hull is 40 blocks. This mode is intended for deep sea exploration, or for remaining completely hidden beneath the surface. It can also be used to avoid detection by radar and reduce the risk of attacks from anti-submarine aircraft. The oxygen system uses electricity and an electrolyzer to convert water into oxygen. The oxygen is then transferred to an oxygen diffuser. For the oxygen diffuser to operate, a redstone signal is required. Inside the submarine's hull, the oxygen diffuser releases oxygen, gradually pressurizing the submarine and forcing water out of the interior. However, this system only works if the hull is completely watertight and airtight. Even a small breach in the hull can cause the entire submarine to flood, even if the oxygen diffuser is still running and producing oxygen. Let's take a look at the radar system. The standard radar provided by the mod has a base detection range of only 20 blocks. Its range can be increased by adding radar dishes and radar plates. Each additional dish or plate extends the detection range by 10 blocks. However, there is a drawback. As the range increases, the radar assembly becomes significantly larger. At long ranges, the entire structure becomes far too bulky to fit comfortably on a submarine. There is also another limitation. If the radar rotates too slowly, detected contacts will disappear between scans. Increasing the rotation speed solves this problem, but does not solve the size issue. To overcome these limitations, I decided to use a plain radar instead. Unlike the standard radar, it occupies only a single block. At the same time, its base detection range is already 250 blocks. The trade-off is that it can only detect targets in the direction it is currently facing. In other words, it does not provide continuous all-around coverage. To make this practical, I designed a dedicated control system. In search mode, the radar continuously rotates and scans the surrounding area. Once a target is detected, the radar can be stopped and manually aligned with the contact. The system then allows the target to be tracked at long range while keeping the radar assembly compact and unobtrusive. The result is a radar system that is significantly smaller than the standard design, while providing a much greater detection range. The only downside is that targets are detected only when the radar is pointed directly at them. For a submarine, however, I consider that trade-off well worth it. The Periscope is built using the Vista mod. It can be raised above the water surface, rotated a full 360 degrees, and lowered back into the hull when not needed. This allows the submarine to remain submerged while still observing everything happening above the surface. It is a simple system, but an essential one for reconnaissance and target detection. The missile system uses rockets from the Create big cannons. Enhanced shells Addon. Guidance is provided by a radar system, working together with a guided fuse. Torpedoes. Torpedoes turned out to be the most difficult part of this entire project. The very first challenge was compactness. From the beginning, I set myself a strict requirement. The torpedo had to fit inside a 1x1 cross-section, 1 block wide, 1 block tall. The next issue was speed. The standard engine simply wasn't powerful enough, not even close. In fact, the torpedo was actually slower than the submarine launching it. Think about that for a second. You could literally outrun the torpedo by staying on course. Not exactly the most terrifying weapon ever created, so I needed another solution. Eventually, I switched to an electric motor powered by batteries from another mod. Conveniently, those same electrical systems were already being used elsewhere on the submarine to power the oxygen system. The electric motor solved one major problem instantly: speed. Lots of speed. As much speed as I wanted. But solving one problem created another. Power consumption. The motor was powerful, very powerful, but it consumed energy at an absurd rate. The batteries couldn't support a fully autonomous launch system, at least not yet, so the first practical version became semi-manual. The motor had to be spun up beforehand. Only then could the torpedo be launched. Not elegant, but it worked. And then, a much bigger problem appeared: the warhead. The standard warheads provided by the mod were surprisingly ineffective. A torpedo is supposed to strike below the waterline. That's where ships are vulnerable, but due to the way damage was handled, the standard warheads barely damaged the submerged section of a vessel. The torpedo could hit perfectly, and still fail to cause meaningful damage. So once again, back to the drawing board. The solution eventually came from a rather unconventional source, a singularity shell. Instead of using a normal warhead, I turned a singularity shell into the torpedo's payload. Then I needed a way to detonate it at exactly the right moment. For that, I used a laser pointer from Create Aeronautics, effectively creating a custom contact fuse. Primitive, simple, and surprisingly effective. At this point, the torpedo finally worked. But the story wasn't over yet, because then the mods were updated, and that changed everything. The update introduced a brand new component, the submarine propeller. Before that update, my submarine used a massive propulsion system built around Create Aeronautics components. It worked, but it was bulky, heavy, and inefficient. The new submarine propeller completely changed the equation. I replaced the old system with 2 submarine propellers. They were smaller, more efficient, and significantly more powerful. Naturally, the next step was putting them on the torpedoes, and the results were incredible. Suddenly, battery-powered torpedoes became practical, the range increased dramatically, the endurance improved dramatically, and the overall design became much simpler. But as always, every solution creates a new problem. In this case, weight. A new underwater mine had been added. Unlike the previous warheads, this thing was actually capable of damaging ships effectively at the waterline. Exactly what a torpedo needed. There was just one small issue. It was ridiculously heavy, one of the heaviest blocks involved in the entire project. The moment I installed it, the torpedo became unstable. Balancing the design turned into a challenge of its own. After a lot of experimentation, I eventually settled on a rather unusual layout. One mine near the front, another toward the rear, and a flotation block positioned ahead of the forward mine. Not pretty, not elegant, but stable, and stability was all that mattered. At that point, both major objectives had finally been achieved. The torpedo was fast, and it was effective. Mission accomplished. But in the end, the torpedo was no longer just an idea. It was a functional weapon, compact, fast, reliable, and finally capable of doing exactly what it had been designed to do. Finally, the Survival-Friendly Submarine is complete, and now it's time to assemble it. One of my main goals while designing this submarine was to make it accessible to as many players as possible. That is why it uses standard Create Aeronautics engines, and the schematic itself uses only vanilla Minecraft blocks for the hull. My original submarine uses armored blocks from an additional mod, but I wanted everyone with the minimum required mod set to be able to build and use the submarine without any extra dependencies. If there is enough interest, I can also release the original armored version of the schematic, and in the future, I may even replace the conventional engines with a nuclear reactor, and turn it into a true nuclear-powered submarine. But for now, let's begin the assembly process. First of all, we need to fuel the engines. The engines power every major system on board: propulsion, steering, diving, the oxygen system, and many other mechanisms. For fuel, I will be using blaze cakes, but you can use any fuel source you prefer. We will start with the main propulsion engines. Then, fuel the motors responsible for diving operations, the periscope, and the oxygen system. Next, we move to the ballast tanks. After extensive testing, I found that in addition to the active ballast tanks used for diving and surfacing, the submarine requires 4 permanently filled ballast tanks. These tanks improve overall stability and provide more consistent depth control. Now, fuel the final motor used by the oxygen system. There is one more thing that must be done after assembling the submarine. The wire powering the oxygen system is disconnected during disassembly, so we need to reconnect it and start the electrolyzer. Next, fuel the motor responsible for rotating the periscope and the motor used by the torpedo launcher. Now let's reconnect the radar and the radar display. Their connection is also lost whenever the submarine is disassembled. To do this, take a data link. Link the first one to the radar display and the second one directly to the radar itself. there's another small issue. After assembly, the radar image usually appears on only one monitor. To fix this, simply replace the remaining monitors. This forces the display to rebuild itself and restores the image across the entire screen. Next, connect the Periscope system. Take the cassette, link it to the viewer. Then insert it into the monitor and provide a redstone signal. Now we can configure the ballast system. Place a throttle lever on the ballast vent. For smoother operation, set it to the lowest position. Then set the speed controller to 32 revolutions per minute, which provides a comfortable operating speed for the system. Finally, provide a redstone signal to the oxygen diffuser. Everything is now ready. The submarine has already been glued together. So all that remains is to activate the physical assembler. And just like that, the submarine becomes a fully functional moving vessel. Let's verify that everything is working correctly. The electrolyzer is running. Oxygen is being supplied to the oxygen diffuser, and the submarine is now fully assembled. With the assembly complete, let's move on to the control systems and take a look at the submarine's controls. Now let's take a look at the submarine's control systems. We will start with basic navigation and movement controls. Movement is controlled using the W, A, S, D, and R keys. The W key is used to increase speed, the S key is used to reduce speed, and bring the submarine to a stop. The R key changes the direction of propulsion, allowing the submarine to move either forward or reverse. The A key turns the submarine to port. The D key turns the submarine to starboard. Now let's move on to the ballistic missile system. The submarine carries a total of 18 missiles. However, I did not want to overload the keyboard with 18 separate launch keys. To keep the controls simple, I designed a two-stage launch system. Missiles are launched using the number keys from 1 to 9. By default, these keys control the missiles located on the starboard side of the submarine. After all desired missiles have been launched, or whenever you wish to switch sides, press the F key. This activates the second launch stage. The same number keys, from 1 to 9, will now control the missiles located on the port side. Pressing F again will return the system to its original state. Next, let's look at the periscope controls. The periscope is controlled using the arrow keys. The up arrow raises the periscope. The right arrow rotates the periscope to starboard. The left arrow rotates the periscope to port, and the down arrow lowers it. Now let's move on to the radar system. Because of the way this radar operates, it requires manual control. For that reason, I created a dedicated control system using a linked controller located beneath the radar display. The radar normally operates in search mode, continuously scanning the surrounding area. To stop the radar and lock its current position, press the space bar. Once the radar is stopped, use the A and D keys to rotate it left or right until the desired target is located. After acquiring a target, the radar can remain fixed on that bearing for observation or tracking. To return the radar to search mode, simply press the space bar again. The torpedo launchers are controlled using two keys. The port side torpedo tube is activated using the Q key. The starboard side torpedo tube is activated using the E key. The ballast system is controlled by 3 levers located behind the control seat. The corresponding labeling is shown on the control panel, where each mode is marked with a letter code. PD stands for periscope depth, CD stands for concealment depth, and DD stands for deep dive depth. From left to right, the levers activate these modes in order of increasing depth, from periscope to deep dive. The long journey of building the survival-friendly submarine, a journey filled with challenges, technical problems, and engineering solutions, finally comes to an end. I would like to thank everyone who followed this project from the very beginning. Thank you for your comments, your likes, and all the support you showed throughout this entire process. Seeing your feedback and enthusiasm helped keep this project moving forward. The schematic is now available for download. Feel free to share your thoughts, feedback, and opinions about the submarine in the comments. And if you have ideas for future projects, especially ones that require unique engineering solutions and difficult technical challenges, leave them in the comments. Maybe the next project will be your idea. Thank you for watching, and I'll see you in the next video.